So I can.
You can't dance anyway.
Yeah, I was gonna go to rehearsals with my chiropractor about it, but I wouldn't be doing it every day. So that was kind of, so I just had her ask.
Makes sense.
That one's excited about. I put that to have fun. Really hard. And then they get everything in there.
I know.
I didn't like that. No, I put enthusiasm for amusement.
Instead of having fun.
I kind of wish that we like studied.
You're getting excited about for like my friends in the house. I guess it kind of works.
It's not totally off.
Get it out.
Yeah.
You're already.
You showed that I can pass. I was confused on number 9 because it said the magnitude and direction.
Magnitude is like the number. Like when we say like 20 miles north, magnitude is 20 or 20 miles to north is the direction. But yeah, we'll talk about that.
Way too much
Well done.
I just had a question about what vector sum was.
Yes.
Okay.
Okay.
I didn't know number 7.
Okay. Let's talk about it. So, on the front, number 1, what did you put? Nonsense.
Nonsense. Really?
F. Yes, because if it already has a constant velocity, there is no force that needs to be required because an object in motion stays in motion, right? Okay, number 2A, is that unbalanced? Yes. Why did you say?
The car is accelerating.
Good. The car is accelerating or it's speeding up or it's changing its velocity. Okay, good. B? No, because
The car is constant speed.
very good. In C,
Yes.
good, because accelerating, slowing down, changing velocity, any of those would be good examples, okay, or good reasons. Number 3, for the first picture, what did you put? C, is correct. The second picture, A, and the third one, B, good. Number 4,
D.
What does net force mean?
net force means that if we factor in all of the forces, they would, if it's 0, they would balance each other out. Like if we set, like when we said the physics book sitting on the desk, if the force of gravity is, 32 meters per second, feet per second squared, whatever, that's the acceleration. Anyways, there's a force of gravity, and then there's the, say it's 20, just make up a number. The force of gravity is 20, and the force of the table, the normal force is 20, then the downward force and the upward force would net to be 0. I don't know if I'm explaining
So
that.
they're at a constant speed, right?
Or it can be at rest.
Or it could be. So it's either
So
C
it's-
or it's either C.
So that would be letter choice E, right? So if the net force is 0, that means that all of the forces are balancing each other out, and so then yes, it would be E. Okay, good. Number 5, the first one.
No.
No, because, good. The second one, Yes.
Accelerating.
good. Is it slowing down or speeding up?
Slowing down.
Which is
Slowing down.
Good. And the last one?
Yes.
Yes.
So,
Speeding up. Very good. Okay. So if you weren't sure what the net force is or the vector sum is, we didn't talk a lot about that honestly yesterday. You probably had a bit of a time with number 6. The first picture. If you think about negative forces, or sorry, downward and leftward forces as being negative, and upward and rightward forces as being positive, we basically combine the ones that are going in opposite directions. So, for the first picture for 6A, the upward and downward forces are what? What's the upward
Equal.
force?
So they're equal.
Right, so the upward is 40 newtons, so that's positive, and the downward we'll say is 40 newtons as well. Since it's going downward, it's negative 40, so the net force of the up and down forces is what? 0. Negative 40 plus 40 is 0. But there's also a force that's going to the left of 10, so this force doesn't have anything to balance it out. So the net force for this vector sum is 10 newtons left.
I guessed on that.
Good. And you do need to say with force, you do need to say the direction that it's going in, because force is a vector quantity. So what would be the net force of the second picture?
0.
0, right, because they balance each other out. The 20 that's going up and the 20 that's going down, so that would be 0. For C, there's 40 going up, so we'll call that like positive 40, and there's 25 going down. So what's the net force?
15.
15 newtons, and which direction?
No.
Right, I'll say up.
Or out.
But yes, that would be fine. It gets confusing if we say north with reading, so.
Because then there's the N.
Yes. Okay. Does that make sense? To notice that?
Well, because it says like, is there acceleration, yes or no?
Okay, so when is their acceleration?
when it's not 0.
When it's not 0. Right, so which ones would have acceleration? The first and third will both have acceleration because they will have a changing velocity. Okay. Number 7, during an in-class discussion, Analytical suggests to her lab partner that the dot diagram for the motion of the object in 6B could be. Anna's partner objects, arguing that the object in 6B could not have any horizontal motion if there are only vertical forces acting upon it. Who is right?
But Anna.
Anna is right. That is correct. Why is she the one that's right? Holly?
I know this is just a gander. Gravity, I said gravity is pulling down and the F norm object must be perpendicular to the contact surface. I said surface, I don't know why I referenced it. I don't know, is that wrong?
It's not wrong, but I'm not sure if it explains why she is right. It's not, what you said is true, but I'm just not sure if that explains it. Olivia?
The direction of the arrows doesn't matter on the graph.
The directions of the arrows does not matter on the graph, that's true. I just said that if it's already in, an object in motion stays in motion if the forces are balanced. so it would have a constant velocity, so if it's already in motion, it could be going in whatever direction it's going, so kind of like what you said, Olivia. It doesn't matter the directions of the arrows in the diagram, it doesn't matter the directions of where the forces are. It depends on what the object was doing prior to that, right? What was already happening, okay, good. Number 8, during an in-class discussion, Aaron, I didn't get this one. His name. Aaron, again, I don't know, asserts that the object in number 6A must be moving to the left since the only horizontal force acting upon it is a leftward force. Is he right? No, he's not. Just like we said before, it doesn't matter what direction the forces are going in, that doesn't determine the direction of the motion. What could be happening there?
The acceleration is going leftward, but the direction is rightward.
Right, so what would that force, I guess it is already labeled what the force is, but that's like the force of the friction, right? So the object could be moving to the right, but the force of the friction is slowing it down. Very good. Okay, so number 9 is kind of a trick question. Which ones did you guys circle in number 9?
With the last.
The diagrams depict the magnitude and direction of the individual forces acting upon an object. Which objects could be moving to the right?
Is it all of them?
So what did we just say?
Doesn't matter.
It doesn't matter. None of the force arrows matter. They don't determine the direction that it's moving. So all of those could be moving to the right.
That's interesting.
Well, then why would they ask a question like that?
So that you know.
It's a trick question.
It's a trick question, but you do need to know that all of them would be possible.
So if they're not labeled, they could be going in
It could be
If, even if they were labeled with the specific type of force that it was, that doesn't affect the direction that it's moving. 'Cause just like we said in like picture A and number 6, that doesn't mean it's moving to the left, it just means that there's a leftward force that's acting upon it. So it could still be moving to the right. Very good. Okay, we are going to move right into the next lesson. If you look on the online, the tutorials, lesson 1 goes straight into the meaning of force, which we've already really been talking about. Or lesson 2. Anyway, so go ahead and write this down. Oh, then you can't write it down. And then we'll talk about it.
Did I ever tell before?
It is.
Isn't that crazy?
It's almost November.
You know, a gander at that point, we use that like all the time.
I still think it's wrong. I have to look that up. okay? Okay. Done with that.
Oh, wait.
Sorry, where are you?
Oh, I'm right at the field question.
Okay.
Why are you scared of her? Oh, that's the best. And then your ears get really hot because the blood flow wasn't coming to your ears. Wait!
When you're sitting and talking,
No.
I assume you're done writing.
I was still doing the column on the other side.
ready to congratulate you. Alright, so we've already talked a little bit about force. Anytime there's an interaction between two objects, there's a force. And then when the interaction ends, then the objects no longer experience the force. So, while it says forces only exist as a result of an interaction, that interaction might not be direct contact, which they talk about here. We talk about here in the next two kinds. There's the contact forces, and then there's the field forces. Or sometimes field forces are called non-contact forces, or action at a distance. So, contact means there's contact, the objects are touching each other. And when two objects touch each other, the force that is exerted upon the objects is in the opposite directions but the same magnitude. So what does magnitude mean? What do we mean when we say magnitude?
The degree of how much.
Like how, it is like how much, so it's gonna be a number. So whatever the number is, in force, we'll see is measured in newtons. So however many newtons, of force is going to the left, the same number of newtons of force will be going to the right or up and down, whatever. It's in opposite directions, but the same magnitude. Field forces only exist whether they're in contact with each other or if they're spatially separated. So gravity, for example, if I'm standing on the ground, I am in contact with the ground, right? And the gravitational pull, we're in contact with each other. But if I jump up in the air, I, for a minute, was not in contact with the ground, but yet the force of gravity was still pulling me, right? And the same thing with the force of gravity of the sun, right? We talked a little bit about that yesterday. So the reason why all of the planets are in orbit with the sun is because of the sun's gravitational pull on us, but we don't ever touch the sun, but there's still a force that's happening there. Other two kinds of field forces are electrical and magnetic. So again, with a magnet, you know, if you have a magnet, two magnets, they can pull together even if they're not touching, right? I keep doing that. Okay. And then all of the different kinds of contact forces we're going to talk about in the next section. The next section is all about the specific kinds of forces and what they mean. So far we've talked already about the normal force and the force of friction. And then the other kinds we're going to be learning about are tension, air resistance, applied forces, and spring forces. Newtons are the unit of force, and it's actually how they came up with the metric unit of a newton is how much force is required to move 1 kilogram to have an acceleration of 1 meter per second. So that's what a newton is. Force, we talked a little bit about this already, is a vector quantity. If you remember way back to the very first thing we studied, vectors and scalars. If it's a vector, it means it has a magnitude and also a direction. So we need to say what direction it's going in, or sometimes we'll represent that with a negative or a positive, just like we do with velocity. If we say it's a negative velocity, we know it's probably moving to the left or moving down, and we can do the same thing with force. And so you've already seen free body diagrams to represent forces with the vector arrows, right? Okay. So that's a lot of information. It's kind of review, some of it's kind of review from what we just got done talking about, and some of it's kind of an introduction for what we're about to talk about, so it's kind of in the middle, transitioning. Do you guys have any questions about any of that? No? Okay. So over the weekend, weekend, I would like you to read the section about the types of forces, because there are a lot of different types. We'll take notes about it on Monday. But it's under the Newton's laws, lesson 2. It's the second one under lesson 2, so I think it says lesson 2B on types of forces. And I will post the link on Edmodo, but I want you to read